So welcome everybody, and thank you for coming to our workshop. And so it's not just me who is doing it. We're a team of 5 people here. It's Evgeny, Boris, Dmitry, and Andrei. So we'll be taking turns, and this is the structure of the workshop. So first, I will do a little introduction and describe in a general idea what you can do if you want to become a core developer, which are the different paths you can take. And then it will be followed by Evgeny doing, what do you want to call yourself? Eugene or Evgeny. So he's going to do show and tell, which is going to be sort of live coding session, about for 40 minutes. And he will try to show you how would you implement a relatively simple AIP in a Go Ethereum code base. And then we will have Dmitry showing how to construct a simple conformance test for this AIP. Then we will break so just before the lunch, Boris is going to give a quick introduction about what you would be expected to do in after lunch, if you're still here. And then after lunch, we're going to try to do it yourself session, which all of us will be available to help you. So you see, there's quite a few of us. So hopefully we'll get you, if you get stuck, we will help you. So let me start. Okay. So basically, there is one of the goals of this workshop is essentially demystify the sort of the core developer profession. I would say is that and to encourage people to try and then just enter this field. And so generally, I would say this might not be entirely correct. You could choose 3 different paths. There might be more paths, but these are the things that I just could think about. So first of all, you could try to contribute code to established implementation, like a Go Ethereum or Parity or something like that. Or you can, you can try to start your own implementation, or you fork the existing one, like we did with TurboGeth. And just do something completely different. Or the third option is that if you don't want to be so radical or you're not sure yet about the coding, you can review the code and write the test cases, which is also appreciated. Obviously, each path has its pros and cons. I'm not going to read it out for you so you can see it. So generally, if you want to be more radical, experimental, you might want to just do the fork of the existing client or implementation or start one from scratch, which is super hard, but it's also very educational. Or if you want to just be very popular and be everybody's friend, you can choose a third path because everybody will love you for that. So then, so as you might know that, so the story of the TurboGeth is that we chose the second path, and but regardless of what you choose, first to the second, so let's say that out of all possible programs that you could write, what actually constitutes a correct, viable Ethereum client? So you could look at the Ethereum client implementation as something which is very heavily involved in data processing. So you can actually, maybe you could sit down, yes. I just wanted to show you the faces, but you can sit down. So it's heavily involved in data processing, and this diagram very schematically shows you the data flow. So as you can see that it's pretty much all about the data processing. So what are your constraints? Out of all possible programs that you could write, what is the correct Ethereum client? So from my point of view, the constraints coming from 2 things. So all the data that is flowing around the Ethereum implementation, there is some pieces of data which are more important than the others, and this is the authenticated data. It's the data that somebody has a kind of put a stamp of approval on, authenticated in some way. And you could think about 2 such important pieces of data: the block headers, which have been sort of approved by the miners by producing a lot of computational work on this. And the block headers contain some pieces of information, for example, the state root, transaction route, and so forth. These are like a short summarization of the content of the Ethereum state, which you know is quite large, or a content of the block, which is the transaction hash, or the content of receipts, which is the result of the execution. So whatever you do, however you decide to store the data, process them, one of the constraints that you cannot avoid is that you will need to be able to compute these 4 things, like uncall hash, transaction hash, receipt hash, and state root hash. You will have to compute them efficiently, so that you should be able to compute them very, very fast and compare it with the block header. So that's one constraint. And otherwise, you're pretty much free with how you do this. And the second thing you need to do is that you need to respect the digital signature. So essentially, the people who are holding Ether, and they're basically entitled to send transactions into the Ethereum network and get it included. So those people are using their secrets, they generate digital signatures, and obviously when they generate those signatures, they construct the transaction in certain format. So you've got to respect that format, and you must be able to verify the signatures. So these are the constraints in terms of data. Everything else is up to you. Like, you can change anything else as long as you respect those 2 things, essentially. Actually, the important bit here is that there are a lot of conformance tests in Ethereum clients, which are actually shared between the different implementation. And this is what Dmitry has been working on for most of his time in Ethereum. So these conformance tests are actually, their main purpose is actually to verify that your implementation actually passes these 2 criteria. And then, apart from being correct, your implementation also needs to be useful, because it's not enough just to verify the blocks and headers. So what is the point of running the Ethereum implementation? Usually, it's either some kind of data extraction that you want to perform. So essentially, your Ethereum node is your window into the Ethereum network. It sort of receives the data from outside, and sometimes you want to query it. You want to either ask questions about the current state or about history, and you either want to get the proof of that or not. So depending on situation. So depending on how you intend to use your implementation, you've got to think about, so will I ever need to query the history? And if you don't, then you might skip some of the things that related to the history. So your implementation might be a bit simpler. So, and for example, the use case of the mining node is that you need to be able to quickly notify your sort of application stack about the new blocks arriving. So that's kind of the block latency. And there could be many other use cases, but that's basically the main things that I could think about, is like you're actually just get some data. So let me see if I think I've got my 10 minutes. So now what we're going to proceed to the second part. We need to switch the microphone. And while we're switching over, any questions?
We're going to implement an actual EIP. I think it was accepted and merged into the Istanbul hard fork last week. So my part is to implement this EIP in Go Ethereum client, and the part of Dmitry is going to implement acceptance tests to be sure that this EIP works well on the Istanbul hard fork. So let's start. Hold on a second. Oh, okay, thanks. Let's read this EIP as a core developer. We can see abstract, motivation, everything is good and interesting. However, as a core developer, I'm also interested in specification. So I can see that this EIP is about changing the gas for 3 operations like sload, balance, ext code hash, and this EIP introduces a new code, self-balance, that should put on the stack the balance of the current smart contract. If you read all these documents, you will find that this API is essential to balance the network, because at the moment gas prices are in balance, and this API should help us to introduce ZK Snarks and ZK Starks and to balance their prices. Okay. Let's go to idea and I think can you read it?
I think you should switch off to the right. Change the background color.
Okay, 1 second, please.
Maybe just black and white.
1 second, please. Nope. Maybe IntelliJ. Yeah, better? Nice. Okay. Let's start from searching where all these constants are present in Golang code. So I'm going to do a simple find on the whole project, and on the second part, we will work on the prepared by us branch. It only differs in one thing. It already introduces Istanbul fork because of it was not yet introduced in Go Ethereum because it's too early to introduce Istanbul fork.
I think if they want to follow along, maybe you can just show them.
Oh, okay.
If you want to follow along, you can clone the specific branch that you created.
Yeah.
We didn't plan for following along, but if you really want to, I guess.
If you really want to, can we send the link?
Maybe just show.
Okay, I'm going to show the branch. 1 second, please. The branch, you can find it on my repository. Here is it. Oh,
just show them the username again and the branch.
1 second, please. It's loading something.
So that's if you want to follow along.
Yeah, here is my name, so you can type it, find this Go Ethereum repository in GitHub, and then you need a special branch. Called workshop. Okay. Okay. So let me continue. I was searching for sload constants in the Go Ethereum code, and the first link that I found is about sload gas price, gas cost. So I'm going to this file, and I'm in Go Ethereum params, protocol params. And I can see here a lot of constants related to Ethereum virtual machine and Ethereum consensus as well, I think. Let's find these constants. Okay, as you can see, we have a bunch of constants for many of operation codes, and they are named in a pattern like the actual operation code, gas, so gas cost, and the fork name. So the only thing we need to do is just copy-paste it and introduce new constant for Istanbul fork. So sload gas Istanbul, and the capital letter, Then we need the same for Xcode hash gas. Okay. Introduced in Istanbul. And the last one is about balance gas. Okay. After Istanbul. So, just FMT the file, one second please. Okay, so then we need to change these values as it is specified in the EIP. So self-balance, balance should be 700. Okay, S load should be 800, and its code hash should be 702. Okay, at this point we have introduced all the constants we need for the first part of the EIP. Okay, can I go further? Okay, then we need to find the places where these constants are used and where they are used in Ethereum virtual machine to calculate the total gas cost of the coal. So let's search for balance gas usage, and the only usage is in core virtual machine jump table. As you can see, this file contains a lot of constructors, and they are construct these types like arrays of operations. We do have these instruction sets for each hard fork. So I think we should introduce a new one for Istanbul hard fork. Okay. New Istanbul instruction set. And if we take a look to another instruction sets, you can see that they are constructed as in a way of inheritance. So they create a previous hard fork instruction set, and then they change things, they change actual operation parameters or introduce new ones. So it looks like we need to do the same because we want to be compatible with the previous hard forks, and the previous one was Constantinople. So instruction set equals to new Constantinople instruction set, then return instruction set. Okay. What next? We have a constructor, but we didn't change anything at the moment. So let's try to change our gas costs for S load. As you can see, this instruction set is just an array of 256 operations, and we can address any operation by its operation code, and we have a bunch of constants for it. So S load, we have constant gas, and we can change it to params Istanbul. So we just change the first gas cost for S load to just introduce the new constant, and then we are going to copy paste this and do the same for balance. Okay, let's check. Do we have balance constant? Yes, we have. Istanbul, balance gas Istanbul, and the last one is about Xcode hash. Yeah, Xcode hash. Xcode hash Istanbul. Okay, we did all the changes in constructor, but it doesn't used anywhere yet. So we need to find where these constructors are used. Let's find this one, new constant instruction set. It's used in two places. One of them our new constructor, and the first one is these variables. Okay, let's do the same. Let's copy paste and introduce new variable Istanbul instruction set. Okay, let's find few there where these variables are used. Okay, here's some interesting happening here. This is a constructor for Ethereum virtual machine interpreter. So this is the thing that that gets this sequence of operations and calls the proper functions for each operation and gets the result. And we can see here that we have a big switch that checks at what fork we are at the moment and creates a proper instruction set for this fork. Okay, let's set a new one for this. Yes, we have a constant for Istanbul already. So if we are on Istanbul, if it is true, then we should use the instruction set for Istanbul fork. Istanbul instruction set. Okay, let's check that it compiles. And so far so good. Our code compiles well, and at this moment we completely finished the first part of the heap. As you can see, it's not very difficult, and you can be a core developer if you can read the code, if you can copy-paste the code, and if you can read the EIP instructions. Okay, let's go to the second part. It should be a bit more interesting because it introduces a new operation called self-balance. This operation code could be used by higher level languages like Solidity, and when this, you can feel that you bring some value to the environment and you bring some value to these such fancy things like Solidity compiler. Okay, let's find where all these operations code are in the Golang code. Second. Okay, we again. I jump again to jump table file because here I saw the balance constant, and I think the self-balance should be quite similar to balance. So I'm going to follow to this balance constant all around the code and check all the places where I need to introduce self-balance constants, functions, and all this stuff. Okay. I think the only place where it is used, where it is introduced, is opcodes Go, and I think we are in the right place. Let's check this file and what we can see here. We can see here a bunch of constants that are sorted by ranges of operation codes, like from 0, from 0x10, from 0x30, okay, from 0x40. Self-balance opcode should be introduced at 0x47. So it should be somewhere here. Okay, 40, 41, 42, 43, 44, 45, 46 is skipped. Let's leave a comment here. And let's introduce 0x47. Okay, then let's check all the places where these constants are used. Okay, the first place, what is it? It's just a map that helps to convert operation code to string representation. Okay, let's add it for self-balance. Okay, next. This, what is it? I think it's a reverse map that helps to convert string representation to operation code. Okay, let's do the same. Okay, let's format the file, and it's all for this file. Okay, at this point we have introduced, I think, all the constant for new operation code. So we can we do have now a new operation code 0x47, and we have the byte representation and the string representation for this operation code. Okay, let's go further. We need, the main thing we need to add this operation code to instruction sets, the Istanbul instruction set. Okay, it should be more or less familiar at the moment. Self-balance. So here we can introduce a new operation. Let's scroll down the file and find something familiar to us. Maybe let's find how the operation balance was written here. Okay, just search. It's changing the gas price. Oh, here it is. Let's copy paste and dig into it in more details. Just in a second. Introduce operation type and format it. Okay. What do we see here? We see a new type operation, and it has a bunch of fields like execute. What is it? Execute is operation function, execution function. Okay, I think it should be a reference to a function that should be called if Ethereum virtual machine interpreter faced with the proper operation code. In our case, 47 self-balance. Okay, so here should be something like operation self-balance. We'll write it in a minute. Then constant gas. Okay, this tells us, yeah, I see it. Thank you. Okay, constant gas. So it's the value, how much the operation costs. If we go to the specification, we can find that self-balance is priced as gas fast step at 5 gas. Okay. Let's find, okay, gas fast step. Yes, we do have this constant. Okay. Okay, we set up this constant gas, it's just gas cost, as it's specified in the specification. Okay, these 3 parameters, I just want to tell that they are used for sanity checks. and we will back to them in a minute. By the way, we'll mark them to be done. To be done. Okay, let's find. Okay, now we need to do a little bit of hard work. We need to write the function that should be called if interpreter faced with the self-balance opcode. Okay, let's find the same for balance, and I'm going to jump into opBalance function, and here it is. Okay, let's copy paste it. Op self-balance. Okay, what self-balance should do? It should get the value of the balance from state, and this balance should be for the current contract. Okay, let's get the value of the balance. Firstly,
can you just explain what is the difference between balance and self-balance?
actually, I want to skip this part at all. Okay. Balance gets from the stack the address of the actual address that you want to get balance, and it writes the balance to this up to the stack again. Self-balance doesn't get anything from the stack because it should already know the address because it is address of the contract. However, it should put the balance of the code address at the stack too. Okay, let's get the actual balance. I think we need the same function because it get balance. It looks like what we need. And then we need to get somewhere the contract balance. Let's check what do we have. We have interpreter, we have contract, we have memory, and we have stack. Okay, we do have contract. Let's check what do we have in the contract. In the contract we have code, analysis, caller, gas, value, address. Nice. Okay, it should get balance to us, and then we should push this value on the top of the stack. Because as you know, the Ethereum virtual machine is a stack machine, and all the code you write, it's stack code, and it do things with the stack. Okay, we need to push this value on the top of the stack. Okay, do we have the stack? Yes, we have. Stack. Oh, it's wrong. Good, thank you. I'm in the wrong place. Stack. Stack. Stack push. Stack push balance. Let's check. Do it compile. Okay, it compiles. So we, at this point, we pretty much finished all the things we need, and we need to sort out these sanity checks, min stack and max stack. Okay, let's return to it. Okay, and let's return to the specification. We can find here that self-balance pops 0 argument of the stack, and it pushes only one value to the stack. Okay, these two fields, let's read about them a little bit. Min stack tells how many stack items are required. Max stack specifies the max length the stack can have for this operation, not to overflow the stack. So it looks like that it is a runtime checks, runtime, I think it's runtime sanity checks, to be sure that the operation doesn't get doesn't put too much values up to the stack, or doesn't get too much values from the stack. Okay, it makes sense for me. And let's set up the correct value. We pops 0 values from the stack and push 1, okay. And the maximum, we pop 0 value and push 1. Our operation is constant, it always push 1 value and pops nothing. So let's check, will it compile? And it's all, we're done. It is a complete implementation of actual AIP for Ethereum client. That's all. Questions?
That's not all. It's not tested yet.
Yeah. We're going to make a full cycle, so we write the code, we've just written the code, and then we are going to listen about the test and write the actual test. Okay?
Can you show the command you're using to build the project?
Oh, it's just make.
Just make?
Yeah.
So you go to here.
Or make get.
Yeah.
It's faster a bit. Okay.
Okay, welcome everybody. I've been working with the Ethereum Foundation since the early beginning. Right after I joined, there were like 3 people working on a CPP Ethereum client, and the major issue we had is testing. So I was hired to help the team with tests. And since then, we have developed a lot of tests. You could follow the repository github.com ethereum/test to see it. It's here. Yeah, here, the test repo we have. I'm maintaining the test repo, mostly the consensus tests, which all clients must pass if they want to be synced to the mainnet. And to find the consensus issue between the clients. So, well, for this workshop, you don't need to clone this whole repo. I have prepared a flash drive with 1 test that you would need, and the binaries in case you couldn't compile, so you will be able to write your own tests. And about the test, so for a long time, every client, it was a client responsibility to make sure that it passes the test, that it could sync up well, and they've been doing it themselves, and I've been creating tests using Ethereum CPP clients, so if we have any new EIP, we had to implement it first in CPP clients, and other clients could run the tests that we generate with the CPP client. This year, I prepared a new software tool for the client developers. It's now called Retest ETH, Retest It. And it could communicate to any client via RPC protocol, sending commands. And with these commands, it tells the client to set up a blockchain with parameters, import some blocks, import some transaction, and then it asks, what is your client state? What is the result of the transaction execution or block execution? And this is enough. It's like 5 RPC methods for the client. And then your client could pass all of the existing state tests and blockchain test also. The state test are the tests that contain 1 transaction. And the blockchain test contain many blocks, many transactions. And your client could even generate the tests. That's the most important part. If you want to create a new EIP, you need to create a new test. And for that, you need a client which generates it. So about retest.eth, you could follow the GitHub repository, Ethereum/retest.eth. And there is a wiki page. I tried to describe everything you need to run to install this tool and to use it with the Ethereum client. And currently, Get client is compatible with retest.eth, and it's fully supported for state tests. And about tests again. In the test repo, if you want, I could pass the flash drive. It's compatible with Linux and Mac. It has the test repo. You could.
We only prepared it for the cases there's no internet access. But
yeah, if you have internet access.
You can just clone it.
But you know, the cloning, when you cloning the test repo, specifies the depth level 1. Otherwise, it's too huge. And yeah, if you need a flash drive, here. So in a test repo, in SRC folder, I keep the sources for all the tests we have. And today we're going to be looking at the general state tests. Each test has a filler file, the source file for the test is called. All those files have filler.json on the ending. And this is a suffix for each file before its test name. And from these filler files, with a simple command, we could generate the result test. And it is stored in the test repo in general state test folder. The filler file contains instructions. It has a pre-section defining the pre-states of accounts in the genesis. It has an expectation section, which is a post-condition that you add. And this post-condition you check after the transaction execution. For convenience, the transaction has some fields as arrays, so you could define many transactions for one state in one state test file. And in the expect section, you could define the post check for each of those the transaction. And once you generate the test, the transaction gets executed. Clients create first clients create a blockchain with the parameters. Then it executes transaction, and then the retesting tool verifies post condition, the post state. You could select individual fields to be checked after the transaction execution, and it verifies that those fields have certain values. For example, you could execute some opcode, put its result in a storage, and check that the storage has certain value. And then in the final test, it puts a post state hash. So when you run this test, you don't need to check the post condition again. It's in a source only, and the clients will just verify that they have the same post hash for each test. That would mean that the state is the same and that there is no consensus issues on all of the clients. So what would we need to run the test generation? First, we need a client which supports these 5 RPC methods for the protocol communication. Right now, it's Go client, and Alex clients and Pantheon, they already support, so I wait for parity. You could compile retest.eth. I would recommend to compile it locally, Docker image, and it's not supported yet, but it's working also. Then you need the test repository with the tests itself. And this useful tool, the LLC translator for Solidity, it's not supported, so you will have to switch to this commit hash for now. And this is a tool used to compile a low-level language into the bytecode, because when you write tests, it's easier to use some language other than typing plain bytecode. So then, in the first part of the presentation, we've been working on changing the actual client, making a new EIP implementation. Then, with this setup, we could start writing the test for that implementation. So imagine we have this whole thing done. Now we could look at the test in the test repo. I prepared an ST example for general state test, an ST example, and this one add 1.1 filler has a lot of comments describing every field for the state test. And so it's an example for the basic result of addition operation with the two arguments, 1 and 1. And in the post condition, there is a check that the result is 2. And it's being put into the storage. So this is like basic example. You could write more complex tests than that. And if you follow the second link, it's in YAML format, not only JSON format supported, because if you need to write a complex code, smart contract code, in YAML format, it's easier. And you could see at that test, like a bit more complex example of a state test. Now let's look at the commands. In the previous session, we have compiled successfully the get client. And if you run it with get retest ETH, it will start listening on a port 8545 by default, but you could set this port. And then you could start using retest ETH, because this, one important part. In the test repo, there is a configuration for retest ETH. There is a folder in the root retests ETH, and there is a folder default. It's a default configuration for retest ETH, which describes where to connect to the client, what fork names are allowed, and in what order, and what Genesis configurations for each fork should be sent. So in the wiki, I have described this whole thing, so you could read. Then what would we need is just to run the retest ETH, specify that we are running general state test, ST example is our test. So by default, the clients will use the default configuration, but if you change this, you want to change this, you could put the configuration name in the client's parameter. And important note, it's a client, it's a folder name, it's not the path to any config file. And then if you want to run specific tests, you could use a selector single test with a test name, no endings, no extensions, no filler.json or anything. And then single net if you want to run on a specific fork. And in this case, we have a new fork Istanbul. And -d, -g, -v is to select a specific transaction from a state test if there are more than one transaction. But those selector, you could just skip, and you could just run all the tests in a generation mode or in a running mode. It's also described in the GitHub wiki. Well, yes, if you have any questions, you could ask me, or you could open an issue in GitHub repo. It's very welcome. It's not so many people working on it yet, so I want to make this documentation as good as it could be, so no question should emerge eventually, I hope. So we have set up the test. The retest need to find the path to the test that we run. By default, it tries to read the Ethereum test path environment variable. If there is no, then it would read 2 folders up. And you could override this by using the test path option. Also important, but like make sure that retest ETH knows where to look for the tests. Then you set up the test client, which we already, for the retest ETH. We could use just the default configuration. This clients section is not needed. Default is run by default. And it is configured to run with the get client on the port, on the TCP socket and the port that get used by default as well. Yeah, and we have a time I could demonstrate it, everything how it works. And currently, retest ETH supports the general state test and the blockchain test in a run mode, and general state tests in a filler mode as well. By running those two major test cases, you would run a lot of, basically everything we have right now in the manual written tests format for the clients, a lot of tests. General state test currently configured to run on a recent fork, Constantinople fix. And there is a new suite. I have a legacy test. It's test cases for all of the previous fork configurations. This is very useful for the clients that are just building and they want to make sure that for any fork they could pass the test and could sync up with the mainnet. And this is a command we're going to be using. The field test tells retested to rerun the test generation process, executing transaction, and checking the post condition. And for that, we use another subsection ST example, because we're going to run our own new test. And some tools for debugging the results could increase the verbosity of retest ETH. And the most important here is a full state, post state. Full state tells retested not to convert huge states into a hash, especially in some test cases where a lot of accounts get created. And a post state tells retested to print the result post state after the transaction execution. So we could see what is the actual post state on our client and could figure out what would we want to add to the post condition. Yeah, some common issues. I also mentioned some of this. These are the frequent questions I get asked when first dealing with retest ETH. Yeah, make sure that test pass is seen by retest ETH. Also, check that your test repo is updated. Check that you have the config for your client. And don't use filler.json as a test name. It's just an extension. And each new test case you add should have in inner JSON the same name as the file without filler.json for the state test. So far those are the issues. And yeah, if you need some online help, better to use my Skype. It's giving me notifications, so I could quickly reply to your questions. And let's begin with the testing.
Okay, let's do it. You're going to be short still.
It's a bit uncomfortable to work in this one. So we have internet connection. Okay, let's start the. I couldn't see the screen.
Oh, no, if you sit down, you can see the screen. Your screen.
It's black. So I have a compiled version of a get from the previous working session. Let's start it in retest ETH mode. Okay, now it should listen on port 8545 for the incoming connection, and the test RPC interface is enabled. Now if we go to retest ETH, careful with the cables. Yeah, okay. Okay, here we could start running the first test, but from which folder? We have
By the way, we will have for the second part, we will have courses going to, in the end, it's going to give you some instructions if you want to download and compile and retest it. So because we didn't actually plan this part to be like a follow along, Dmitry just quickly show how to test this particular AIP, right? Just one simple test.
yeah.
And Boris is going to show the instructions for the second part.
So here we have the test report. Let's look at default configuration that I mentioned. Here's retest ETH inside the test folder. The default configuration looks like this. Let's look at the config. So here we have a Go client setup using TCP socket, using these ports to connect. So there are many ports because retest.eth could run testing in threads. So you could set multiple ports and run multiple threads. And then fork names that we are going to be using. It's exactly the same order, one by one followed. Because tests support the post condition specification, like you could set a post condition for each fork starting from Homestead, for example. And this would be the order. And the configuration, the Genesis configuration for each fork. Like we have a new configuration here for Istanbul. Here are the parameters for the setChain params test method. So we have specified that now Istanbul fork block is 0, so it should be active from very first block. Here are the precompiled contracts described for the specifications, not just some basic stuff. And here's another file, correct mining reward. This one, initially state tests were not like blockchain. So mining reward is not calculated in state tests. But now when we run it through the RPC, it is the same as running as blockchain because we are telling the client to start execute transaction and mine the test block. So I need to correct the mining reward for the Coinbase with each test. This file just describes what would be the mining reward, and just to explain the meaning. Okay, and then let's look at our test. It's SRC folder. Here's the sources for all tests we have. A general state tests folder. Here we have a lot of different tests. Let's look at the ST example. Here, the one I mentioned with a lot of comments, add one. And for the previous change that we made to get client, I created a copy for a balance instruction and how much gas it should now take when running on Istanbul. So balance opcode result and how much gas it will take. First, we need to set up the pre-section. These are accounts that are going to be existing from the Genesis state. This address is the one that's going to be sending it. It's a call address. It's going to be sending the transaction. And the transaction itself, it has as fields data call, the gas limit of transaction, gas price, all the basic fields. Here, the most important would be the secret key. This is the secret of that address I mentioned. And this transaction going to be sent to this contract address. Value could be skipped, actually. It's a balance that you send. So let's look what is the contract code then. Here is this address in a pre-state. It has some balance, some previous codes. This one is not actual. Here's the code, because I expect that not everybody would be able to use LLC maybe for some reason. That's why I put compiled bytecode, so you won't need LLC compiler. But if you have LLC installed, you could type it right like this, because it's a state source. This is a readable code, so we want to check the balance, calling balance instruction of the caller itself, put the result into storage 0. Then we checking how many gas we spent on this instruction, and we put the result gas remaining into storage 1. And below is the bytecode of this operation. So for EVM, it's already compiled. But if you have like LLC tool, it will be compiled on the fly into bytecode. And this is a post condition that we need to check. So select transaction. We have only one transaction for 2 forks, starting from Constantinople fix, and we added Istanbul fork, so it's going to be 2 forks. We're going to check that in the result for the contract that we called, here this is a contract, we have exactly the same, like the most important here to check is storage, that we have exactly these values. This is the result of a balance, of course, at the storage cell 0, and this is the remaining gas at storage cell 1. So those are expected results for these instructions. And that's basically it. That's what we are testing right now. We're going to retest ETH. Let's select our test. And run. So right now, retest ETH used this test balance from this file. It tried to use already compiled version and run it against the get fork that's currently listening on the port that we specified.
Can you maybe show the console of the guest, what it shows, because it's also interesting. So you can show that they actually communicate with each other. Yeah, that one.
The get result. What's the most interesting part here?
Yeah, basically the interesting part is that when you have these DAO support chain config, is this where the retest test resets the chain. Every time that you see this line, this is where it starts executing a new test. So
yeah, it should have like 2 forks.
Try to do the same call on the top and by leaving the bottom running, and you can see how it happens.
Ah, yeah, that would be interesting.
Just try to do
Let's generate the test now.
See, it's something happening down there.
So it's here rebuilding the blockchain because we have 2 forks. First one fork for Constantinople fix, then for Istanbul, and we have an error. So apparently incorrect storage. The result from the clients.
Can you maybe highlight this so it's not really visible?
Yeah, I will. Is this better?
Yeah, just highlight the whole red message because
Oh
it's very
yeah,
light,
let's.
color to see.
Is this better?
Okay.
Anyway, so the result storage at cell 1 for the contract. For this contract, the result storage from the client is this 057794. But we put in our post conditions that we expect this storage to be set to this 0578C0. So we have an error. And this is because we have changed the cost of a balance instructions. We have exactly 1 balance instruction, and now the result different for 300 gas. The result is different. But you see this error occurs only once for the fork Istanbul. That means that the fork Constantinople fix doesn't have such an error. So the gas is the same as what we expected it to be on the fork Constantinople fix, but not on the fork Constantinople, not on the fork Istanbul. So that's it. That's the process.
Can you fix the test?
To fix the test, it would be better to create a new post condition section here for each fork. And here where the manual part starts, Like when you're creating the both condition, you mentally verify that this is the result that you have expected. Otherwise, you could check something wrong. But we have many clients. So even if you have a wrong expectation, another client running this test will disagree with you because they could have implemented it differently. Maybe their version is correct, maybe yours version. Well, you need to investigate. That's how we check what are the difference when running the tests. And this is a basic example of the gas price change. But there are some tricky cases where some opcode being called from the subcall, which is delegate call or a certain depth level, and not all the clients behaving the same way in such situations. It's getting complicated, especially with the revert opcodes and out of gas calculations when you need to reset the state back. So now we have two expectations, one for Constantinople fix, let's put, and one for Istanbul. What we should still see the error, because I just split it. Okay, fork Istanbul has this error, so the client return parameter was this one. So let's imagine we have this error. We checked why. We know that this is actually correct for Istanbul, the gas price. So now we set in a test that, okay, the gas price here is expected to be this one for Istanbul, and that one for Constantinople fix. Generate it again. So, and the test generation went without errors, just that we don't have LLC for the version to put into final test. This we could solve. Like, no, I'm just installing LLC back again in the system. Generate the test. Okay, no errors. In LLC version is in the final test. Let's look at it.
So you want to see what it ended up being?
Only feeders here. The final test is generated in the folder here, general state test, st example, the balance.json. Those are automatically generated test cases. They don't touch. Here are our tests. This is how it looks when it's generated. Some comments about which software we use to generate the test. Genesis block configuration, and a post state that we have after the execution, the transactional execution. For the Constantinople fix, we have this post route. For the Istanbul, this post hash. This is our pre-state with the compiled bytecode. The source you could see in a test filler. This is our count and transaction. Transaction with these parameters. No data, this gas limit, calling this contract. So it should run it. And here, how it works. Currently, this test could be converted into a blockchain test and run by the Hive tool. And Go and Parity have the parser to run this format. But they don't really need it now. If they just implement retest ETH support, its test methods, they could run it using retested and even we plan to set up a server which could run tests all the time using retest.eth and the recent Docker images provided by the client developers. So they won't need to parse this test format because it could change. Don't need to worry about that. And if you're implementing the client, you could use retest.eth tool to check, to write your own test in the first place and to check that you're passing the legacy test. And if there are some errors, you could debug it. There is also an option to attach to your client on an IPC socket in debug mode, so you could debug your client when using retest.eth. I plan to continue this work, this development of the protocol, maybe add a new methods for the test interface that provides some debug information from the client side, or some other test methods to generate malicious blocks. There are many interesting things I have in mind. So right now it's oncoming blockchain support. Maybe I could set up networks and see how clients interact with the same network. And what I really need is help on writing the actual tests, more developers, because there are many EIP proposals, but not so many tests. And nobody from the even the EIP proposals, they don't do any tests. So it would be wonderful if the community start doing the tests and provide contribution to this EIP. That would really help to integrate them faster. Yeah, questions?
Is there any website that we can see the test result on the different implementations?
Oh, there was a Hive stats running all the tests. It's currently not updated. It has, because you see, I changed the format of some tests or the location, and now Hive needs to update. So I think it was Hive stats, etherstats.net.
Can you share the URL?
But you could ask Martin Holzwender, he supports Hive. The Hive still gonna be working. I think we will update it for Istanbul. Retest.eth is more of a new tool, but it's already could run the whole general state test. And the original prototype of retest.eth, test.eth from the CPP client is a backup version for all the tests, all the new tests that is going to be for Istanbul.
Yes, so this particular, you see that in the git clone instruction, so it's important to choose the branch workshop and to do recursive. Was it DappCon? Yeah, it's recursive because, so if you don't do recursive, it will not, so basically Go Ethereum repository is connected to the test repository through the test data folder. So if you do recursive, it will establish that connection straight away. If you don't do it, you have to do some sort of git submodule update or something like that. And also, if you don't do the branch straight away, you have to do the git checkout, but then you have to update submodules again. And the DappCon is to reduce the download size. So basically, yeah. And then actually, is LLC strictly required? Maybe.
I think no.
No.
But it'd be great if you do it.
So if you have trouble with LLC?
Contains of 3 steps. We can implement the first EIP. We're going to implement EIP 2028 related to reusing data transaction of call data. The previous value was 68. We need to reduce to 16. It's quite simple, but we need the simplest EIP to show how to implement EIPs and how to write in test for it. So the first step is prepare environment. We need to Golang install it. We need the custom branch of Go Ethereum. And if you want to write tests, you need to download and build retesters and LLC. Next step is implementation details. You're going to implement this AIP, and next step is testing. The link of this document is here. See you on the next part. Hello, guys. I think we can start. Everybody prepared environment. Here's a link to the instruction guide. Everybody have prepared environment, or we can do it together. Okay. So, I think we can start. We're going to implement EIP 2028, reducing transition gas cost. Here is the EIP. We need to change current value of 68 to 16. Let's prepare environment. We need to clone our Ethereum branch, which is prepared by Eugene. If you have any question, you can feel free to ask. We'll try to help you.
So there will be basically all of us here, so all the, so I think it's five, there should be five of us. Is that right? It's only four. Anyway, so we're here to help you. No, there's another one. Oh, yes, okay. Essentially, you try to do it yourself. If you have any questions, you can raise your hand or just ask about it. We can come to you and help you with anything you want. Or if the question is interesting enough, we can discuss it.
I'm going to go Ethereum from Eugene's branch. We need to do with the recursive option because it contains Ethereum state tests, which is supported by V3.
So let's do the question, the hands. Who wants to attempt to do this now? How many people want to do it? Or how many people just want to say sit and relax? So can you do it again? How many people want to do it now? 1, 2, 3, 4, 5. Okay, right. Let's do it.
So we cloned Go Ethereum. After it, we need to install tools for testing. It's a retester, and we need to install Solidity. Okay, I'll try. So when installing retester, using this small bash branch.
Just another question. Where can we find that? Yes.
Oh, yeah. This is a link. This is here. So everybody opens it.
Okay. So LLL was one of the first languages that, so even before the Ethereum launched in 2015, the Gavin Wood and C++ team was working on a series of prototypes. There was like POC, whatever, 4, and that client that was like a UI built in C++, and inside you can actually type this LL code, and that you would use it to generate the bytecode of EVM. There was no Solidity at the moment, at that point, and nothing. The only language you could actually have is this LLL. the nice thing about this language is that actually it's very easy to understand what bytecode it would produce. So it has no kind of code, pretty much no code generation. So you can figure out, it's very low level essentially. So if you see the very simple code, you pretty much can guess what the compiler is going to do in there. So there's no like magic and trickery in there. I guess Dmitry, who had an idea to use LLM in the tests? Christoph. Oh yeah, Christoph Jensch was the person who started to do the tests in this format. He had an idea of it would be nice to, instead of putting bytecodes in the code section of the contracts, which then you can, sometimes it's impossible. For some of the tests, you look at the bytecode, it's like, what is this? It's like hexadecimal string. So it was a bit nicer to have a level. Still very low level, but you can just figure out, okay, this test does this, puts it in the storage and stuff. But for this particular workshop, it's not really a requirement. You could try to do that because the test we have is so simple that you can just do the bytecode, which is 4 instructions. 4 bytes basically. And I think Boris can explain you what these 4 bytes are a bit later.
So I wanted to say a couple of words about this particular approach of compiling Go project with make. It's actually not, it's an unorthodox way of compiling Go. Usually you would use something like Go modules and stuff like this, and actually the Go modules is becoming much more mature. But because the Go Ethereum project has been created a few years ago, they created makefile, and sometimes you have to turn off some newer feature of Go to make it work. So this is not like the best way to compile your Go project. So, but it's just there. Anyway, I think experience of building some seemingly unrelated C++ project, and then just prepare the Docker containers. But actually, I think it's a part of the valid part of the experience is that you should be kind of brave and not being shy to, let's say, okay, I'm a Go developer, but I have to build a C++ project. That's fine. You can figure this out. There's the build steps and stuff like this. So if we prepared all the Docker containers for you, it of course might be a bit smoother, but you wouldn't get that part of experience. So.